Continuing the chain rule, let's look at page 290 where there is example 3.51. There is so we have an h of x and it equals the cosine of g of x. We don't know what g of x is, so we're just gonna leave it as that and just go as far as we can. Now by the chain rule, then h prime of x is, by the chain rule, you take the derivative of what is on the outside. In this case is the cosine of something. Okay, the derivative of cosine is negative sine. So that's the rule we go by. So we get negative sine of whatever's in there. All right, so, and that's done for the first step. The second step is we need to figure out what's in there. What is in there? Well, what's in there is gx. G of x is in here, and we need to take the derivative of g of x. And the derivative of g of x is just g prime of x. Being that we don't know what g of x is, we'll just write that down. And that is the final answer. See? Piece of cake, right? So please do example 3.52 by yourself. It's also very short. I'll write it down here. As part of homework, do example 3.52, which is a very short and sweet example. Next, let's look at example 3.53, which is, I guess, is slightly more complicated. Maybe it's worth doing. Example 3.53, have you do some kind of a composite trigonometric function, secant of some, this is called a binomial, two terms. Oops, it's not 4. I mean, it's not 5, it's 4. 4x to the power of 5 plus 2x. So we have that. When you have that, first we need to take the derivative of secant. What is the derivative of secant? The derivative of secant, if you look it up, or remember it, it equals to secant tangent. That's just the rule. Now, after I have looked that up or remembered it, then we'll follow this rule to say that h prime of x, the derivative of h equals the secant becomes secant tangent. Secant stuff, we'll worry about the stuff later. Tangent and stuff. And what's the stuff? We'll copy the stuff down. Okay, there's all the stuff. We're not going to pay too much attention to it yet. We'll just copy it down. 2x. 4x5 plus 2x. That is all fine. However, next step of the chain rule is that now you have to take the derivative of the stuff. Okay, what's the stuff? Is these things. So taking the derivative of this stuff, then we get the power rule. 4 times 5 is 20. X to 1 less power, which is 4. We'll put it in parentheses, plus 2. And this big long chain of things, exactly your answer. So you get 20x to the power 4 plus 2, secant of the stuff, and tangent of the stuff. See? Again, it's short and sweet. The chain rule is often short and sweet. It's a quick way to, yeah, it works very nicely. So that's example 3.53. Now, if you look at page 292, there's a theorem 210, which repeats the chain rule for the trigonometric functions. I don't know why the book thinks it needs to say that, so we will skip it. And next, let's look at example 3.54, which is longer. Okay, example 3.54, which is on page 292. Yes, example 3.54 has a bunch of powers, which you can, even without the chain rule, you can technically do it by, well, multiplying everything out, right? But we're so not going to do that because we got the chain rule. Why are we multiplying anything? and do all that grunt work when we got the chain rule to, well, get to the result faster. So example 3.54. This is on page, where did I say the page is? Page 292. Where we have to take the derivative of this thing called h of x equals to 2x plus 1 to the power 5 times 3x minus 2 to the power 7. Okay, now you look at this thing, there are two objects here. So normally we have like sort of one thing. Now we have two. What do you do with two? Then you think of it as two things. So we'll apply the chain rule in this way. Okay, so h prime of x equals, first we will consider, we will first remember the product rule, right? The product rule says the derivative of a product, which you have right now, these are products, equals to how will we do that? The first, what did I say? Derivative of the first times the second plus the first term times the derivative of the second. Derivative of the first, see, is symmetrical. Very easy to remember. Each item gets to take derivative once and get to be itself once. Okay, and then it's multiplied together and then added up. So that's the product rule. Having remembered the product rule, we will apply it here. So we'll follow this one. This is f. This thing inside here is f. And this thing, yeah. No, not inside. This whole thing is f. Okay, we'll call this thing f and that thing g. So h equals to f times g. This is h. Now, having said that, let's apply whatever need to be applied. So applying the product rule, it says that the product rule says that we take, we'll write down the first term, which is f. F is 2x plus 1. We'll write down the first term unchanged. Okay, then we'll take the derivative of the second. The derivative of this thing by the chain rule is 7 times what's inside to the power 6. And then the derivative of the inside. So what's the inside? The inside is 3x minus 2. And if that's the case, then the derivative of the inside is 3. All right, so far we've done this part. So we did f prime. No, this is only f prime. We only did this part. We haven't multiplied by g yet. So we need to multiply by g according to plan. So what is g? G is what? No, sorry. I saw the wrong thing. Isn't I took the first term times derivative of the second. So I did this one first. All right, which is okay. And then, yeah, that's that. And then plus the derivative of the first term. We'll do this one, but take the derivative, which is 5 2x plus 1 to the power 4, and take the derivative of this one. The inside is 2. Okay, that's f prime, and then multiply it by g. G is this one right here. This is g. Okay, we'll draw this thing out. That's f. Is the whole thing. All right. So f prime, that's that, times g. So we'll write down g. G is still 3x minus 2 to the power 7. So I did this one first. So let's double check our work because it gets a bit confusing. So f, we do this one first. So we have, this is f, okay, times g prime, that's g prime, okay, that g prime, and then plus this thing is 5 2x plus 1 to the 4 times 2, that's f prime, okay? And then times this thing is just g, right? Times g. So that should be correct. See, I have reversed this thing by accident, but it doesn't matter which way you do addition. You know, you can do this one first or that one first. It's the same. The point is, we did this particular formula, and this thing, after we clean it up a little bit, will become is h prime of x. All right, now we have to clean it up, which is okay, I guess. Let's clean it up. Sometimes is good for you to do some grunt work, you know, build character. Like all suffering builds character. So let's clean this up. To clean it up, we'll look for common factors. We'll write it back here. So this h prime of x equals to, there's 2x plus 1, 5 to the power 5, 2x plus 1 to the power 4. So 2x plus 1 to the power 4 would be our first common factor. And next, there is 3x minus 2 to the power 6, and then 3x minus 2 to the power 7. So 3x minus 2 to the power 6 is our next common factor. And then there are some numbers, 7 and 3 and 5 and 2. There is not much going on there. So we have that, and then we have what's left is, so we took 2x plus 4 times, so we have 2x plus 4. There's one of them left, times some numbers, which is 7 times 3, which is 21. And then plus, we're still within the parentheses, 2x. So 2x plus 1, there's 1 left, times 21, all right? And here we have 3x minus 2, that's the only thing left. 3x minus 2, just one of them. And then the numbers, 2 times 5 is 10. All right, so this continues here, all right? I just ran out of space. So next, we have, that is we're getting pretty good. And then now we have to sum it up. So to sum it up, do the rest of the math. So we will write this down, 2x plus 1 to the power 4, 3x minus 2 to the power 6, and then we do basic, now we need to do addition. I'll stand over here and let's do that's, how many x's are there? That's 2 times 21 is 42, plus 30 is 72. So there are a total of 72 x's. And then 4 times 21, and then minus 20. That's 84 minus 20. Let's see. Give me a second. Sorry, I made a small mistake here. There is 2x plus 1. I don't know why I wrote down 4. It's not 4, it's 1. What? All right, so let's fix this thing. It's actually 1. All right, which makes it, that's plus 21 minus 20, that's plus 1. And that is the right answer. See? If you, grinding through all the stuff, you don't make any mistake anywhere, then you get to the right answer. If you get to the wrong answer, better do it again and see where you wrote the wrong thing, like I did. So that's that. All right, so next we will look at derivative of even more layers. There's you take one layer and then there's something inside and there's something inside that. And to do that, let's look at example. Well, turn to the next page, 293. The derivative of 3 of them is, well, you just keep going, right? You apply the principle of the chain rule, and that can be applied indefinitely. You just keep peeling your onion until it gets all peeled. So as an example, we'll look at 3.55 after I clean off the board. Example 3.55, where we have k of x equals to cosine to the power 4 of 7x squared plus 1. All right, there is remember that what this means, that the cosine isn't being raised to the fourth power. It's the whole thing that's being raised to the fourth power. That's what this means. Cosine 7x squared plus 1, the whole thing in parentheses raised to the power 4. In other words, this thing is multiplying itself 4 times. We write it this way because that's a tradition. Respect the tradition. So now let's see. All right, so we are going to apply the chain rule. So k prime of x equals to, well, first there's a lot of stuff here, but what's on the outside is something being raised to the power 4. So that's what we're going to focus on. Now when something is being raised to the power 4, we apply the power rule, which means we take the coefficient, right? And then we write down whatever's here, and then we raise it to a power 1 less. So that's so far so good. And then now at this point we can't stop because we now have to take the derivative of whatever's in here. Now what is in here? What's in here is cosine of 7x squared plus 1. That's what's in here. So we keep going. We need to take derivative of this thing. Okay. Now the derivative of this thing, the derivative of cosine is negative sine. So the answer is, we'll draw some parentheses, negative sine of what's in here. That's the derivative of cosine. The derivative of cosine is negative sine. And whatever's in here. Now what's in here is 7x squared plus 1. And that thing, we have not come to the end yet because we're taking the derivative with respect to x. So we got to hit the x, get down to x. This is only 7x squared plus 1. So we take the derivative of the inside. See, this is the second inside we're doing because this function has 3 layers. So we need to pull the chain rule 3 times, whereas normally we'll only do it twice, right? And then so we'll do the derivative of the inside, which is 7 times 2 is 14x for this particular thing. The derivative of constant is 0, so we'll ignore that. And that, now we have come down to x, and that's the end of our chain rule operation. And therefore the k prime of x, that is the derivative of k with respect to x, is all this stuff. And then we will line it. This is not subtraction, this is just a minus sign. So we'll line up all this stuff, okay? And maybe even do some calculations. 14 times 4 is 56 times plus the negative sign. So minus 56, that's all the numbers we need to worry about. All right, and then I guess we'll write this one first. Sine of 7x squared plus 1, and then where's the x? Oh yeah, I forgot the x. X right here. Let's write down our x. Let's not forget the x. 7x, we'll write down the sine term first. No reason. And then we'll write down the cosine term, which is cosine of 7x squared plus 1 to the power 3. The whole thing is to the power 3. See? So by tradition, we write it the power 3 right over cosine. That means, yeah, and that is correct. And then let's, having seen that, my screen is frozen. Come on. Give me a second. Now example 3.56 is a fairly straightforward problem, so I will assign that as homework that you should do it yourself. The same as 3.57. Again, it's slightly interesting little problem that, but doesn't take, I don't think there is much to it. So let's move on to page 295, where we will look at the Leibniz notation that your book wants you to do. I don't know that that's necessary, but being that they have it written down, let's look at it. 295. So on page 295, we look at the Leibniz. Actually, I'd rather not say his name, but whatever. In fact, I think I'll call it the dy by du notation, because that's easier to remember. And what that is, what it is another way of saying the chain rule. So instead of that is yeah, dy by dx. Okay, I should write this down. Dy by dx equals to dy by du times du by dx. That is the chain rule. It is what we've been doing this whole time, but we'll say it slightly differently. Okay? And as an example of what I'm talking about, let's look at example 3.58. So example 3.58, where you have to take the derivative of y equals to x over 3x plus 2. And this whole thing is raised to the power of 5. Now, how would you take the derivative of this with the chain rule? Normally, I would do it a certain way, but right now we'll do it by the Leibniz notation, which is actually the same way. But you just call it by a different name, like the rows by a different name. But it's exactly the same thing. So we'll do what it says. Okay, so what are we supposed to do? We'll let u equal to this thing. We'll pick a u. So where's u? U is right here. U equals to the inside. X over 3x plus 2. All right. And then if that is the case, then y will be equal to the u to the power 5, right? Right. And then following the chain rule in this version, we will say that dy by dx, which is the derivative, okay, equals to dy by du. Y is 5u. Okay, dy by du then is 5u to the power 4th, according to the chain rule. Then we calculate du by dx. What is du by dx? Du by dx is, we gotta apply the quotient rule. Now, so let's remember what is the quotient rule. Here's a quotient here. The quotient rule is the bottom, okay, times, so you have f of g over g, right? That's your quotient. The quotient rule says the derivative of f over g is you take the bottom times derivative of the top. That's how I remember it. Remember however you like. Minus the top times derivative of the bottom all over the bottom squared. That is the quotient rule, I believe. Anyway, so following that rule then du by dx equals to, we'll do the quotient rule. As I said, the bottom, 3x plus 2 times derivative of the top, which is 1, minus the top, which is x, times derivative of the bottom, which is 3, and then all over bottom squared. So that is 3x plus 2 squared. And this thing simplifies into something like 3x plus 2 minus 3x. There's the 2 is left, right? 2 over 3x plus 2 squared. Right? Yeah, it looks okay so far. So, and then next, we will, then now we'll stick that thing in here, what we did before. So dy by dx is dy by du, which we did a little earlier, and then du by dx, which is that thing. So we'll write it down. 3x plus 2 squared. All right. And that's the answer. However, we still have a u here. What was u again? U is this thing. So we need to copy it back in. 5u, which is that thing, 3x plus 2. And then times this pile of stuff, 2 over 3x plus 2 squared. And so you can clean it up slightly to become 2 times 5 is 10, x over 3x plus 2 to the power 3. And well, this is exactly what I would have done if we had just followed the chain rule. Okay, I would have taken the derivative and gotten to this point, 5u to the power 4. Let's not forget the 4. I would have gone, what? Give me a second. No, I forgot the power 4. I need to fix this mistake. All right, so 5u to the power 4, that's 10x. There is 4 here, right? And there's 4, and 4 plus 2 is actually 6. Yeah, I forgot to write down the 4, and then I have to pay for the mistake by being wrong, unfortunately. But the good thing about math is that you can always find your mistake, right? Certain other disciplines, you can be wrong for years, and nobody can tell. But anyway, but in this case, this is right. Yep, it's correct. So now that we have this, if I was just doing this without using this trick, I would have just taken 5 and write this down, and power is 4, and then taking the derivative of the inside of this, which is, well, I'll get through this step and get here, and then that will be the answer without making mistakes. And so that is the answer either way. Now, some people might find the dy by du notation easier to remember, and others might not. Either way, remember, this is not a fraction, okay? This is taking the derivative with respect to u. In other words, u is your new variable. And some people might find that easier to understand or remember. And if it does, there's nothing wrong with using it. You know, use whichever tool that is that you're most comfortable with. With that, we have come to the end of the chain rule section. Remember, the chain rule might seem a bit weird. And to be good at this chain rule, there's only one trick, is practice. Do a lot of homework. That's why for this section, I have 2 separate homework parts. The first part is shorter, which you have hopefully have already done. And the second part, which is assigned here, and I have, besides the examples that I mentioned, and of course you should always redo the examples that I did in class, and then the examples that I didn't do but assign. And then for problems, I chose 215, 17, 19, 25, 35, 37, 39, 43, 47, 49, 57, and 59. And then so please go do your homework, and when you're done, if you feel like it, come back and watch me do some of the examples. The examples that I have starred will be the ones that I intend to do in the video. But if you feel good about all the homework and confident, you can just skip the rest of the video. There's no point in watching me do something that you already know how, right? So now that you're done with the homework, let's look at a few problems that I find somewhat interesting. Now, problem 239. This is on homework page 297. Page 297 and homework problem 239. Number 239. All right, you have some kind of a function, y equals to all the stuff, f of x plus 5x squared, and then everything to the power 4th. So slightly complicated. You're going to be using the chain rule, of course. Now, and you are giving various information. First, f of minus 1 equal to 4. All right. And then you know that, and then also if when x equal to -1, dy by dx equals to, what was it? 3. Next piece of information. And then, okay, that's this. Yeah, this information is together for when x is -1, dy by dx is equal to 3. And then what are we supposed to do here? You're supposed to find, so here's what we're hunting for, f prime of 1. What is the value of the derivative of f at -1? Sorry, -1. All right, so that's a bit different, right? And different is good. It makes it somewhat more interesting. How would you go about doing that? Well, it's kind of a bunch of mess with miscellaneous information. Hard to tell where to start. So what do? You take the derivative, because that's what we've been doing, and apply the chain rule. And therefore, here's our equation to take the derivative of. So y prime equals to, there's y. I take the derivative, which is, you write that thing down, apply the power rule, okay? The power rule says if you have stuff to the power to take the derivative, you write down the highest power and then reduce the power by 1, okay, of whatever's in there. Now, next, we need to consider what's in there. If what's in there isn't x, then we need to work on it some more. So what's in there isn't just x, so we will write down f of x plus 5x squared, and that is the entire inside, for which by the chain rule we need to take the derivative of this thing and multiply it. To take the derivative of this, then it becomes the derivative of f is just f prime. All right, we don't know what f is, so we'll leave it at that. Plus, this is a simple power rule. 2 times 5 is 10. 10x. All right, and that's that we have come to the end of it, right? All right, so that, what about it? Now we have some information regarding to this equation. That is the y prime, which I've written down here. Y prime is just another way of saying dy by dx. Okay, there's more than one way to say the derivative. They both say the derivative. All right, there's this situation where it says that the dy by dx is equal to 3 if x is equal to -1. Okay, and that's what we're going to do. We'll put all x's as -1, because this relationship holds when x is -1. That's as we are given. So so let's write that down. F of -1, all right, and plus 5. -1 squared is +1. And then f prime of x, which is f prime of 1, because x is 1 at this point, plus -10, right? Yeah. Anyway, 10 times -1. So that's x is -1, so that becomes -10. All right. Now, as you can see, we're looking for f prime of -1, and sitting right here. That's what we're hunting for. And this is a nice clean equation that if we were to solve it, we'd be able to come up with what this is, except for that. What is that? That is actually given, is 4. This thing is 4. As is given to us right here. And so now we have a complete equation to solve for this unknown, okay? And then, all right, so after that, then now we're just doing plain old, good old algebra, and hope not to mess up. Let's, so then that becomes, that's still, we'll write down 3. 4 plus 5 is 9. No, it says -4. What? Give me a second. Let's see. Minus plus. I made a mistake. F -1 is given as -4. Okay? And I didn't mess up. When I did this problem in preparation for this class, I got it right first time. Take a look. But when I wrote it here, I messed up somehow and forgot the minus. And then, It doesn't come out the same. Anyway, the point is this thing is minus 4, which will look much better. Okay, so because minus 4 plus 5 is just 1, 1 to the power 3 is still 1. So so that whole complicated mess is just 1, which is very nice. And then times f of 1 minus 10. Okay, this equation still holds. So then you solve the equation. That becomes divide by 4. Okay, so it becomes 3 over 4 plus there's plus 10 equals to f prime of 1 by the time you get through the pre-algebra. And at this point, and so that equals to 10 3/4, which I checked the answer and I was right. See, I did it right the first time, but not the second time. I messed up the second time by forgetting the negative. But all's well that ends well. Next, let's look at the next problem, 249. Yeah, all right. 249 in the next page, I believe, is you have a big old chart, which I'm not going to copy down, okay? So here's your chart in your book, and then the chart gives you all kinds of values. There's some 16 values of various things, and you will judge by the chart to crank out what you need to figure out. So number 249, let's look at this. The problem is h of x equal to f x plus f of x. Yeah, I chose this problem because it has f on the inside and the outside, which I thought make it slightly more interesting. Where a equals to 1 and you're supposed to do something. What are you supposed to do here? 249, you are supposed to do, well, you're supposed to do something. What does it say? Use the information to find h prime of a. So we're supposed to find h, what am I doing? Find h prime of 1. Okay, a is 1, so we're looking for h prime of 1. All right. Now to find h prime of 1, and how are we going to do that? Well, we have nothing else to do around here, so we will do the derivative and apply the chain rule. The fact that there's f in here and out here doesn't change a thing. Okay, you apply the chain rule as if they're different people. They're the same, but same, different, there's no difference. All right, so calculate h prime of x. It equals to, by the chain rule, first you take the derivative, which is f prime of this stuff in here. Okay, that's the first step of the chain rule. And then second step, if the inside isn't just x, then you have to take the derivative of the inside, which is, well, let's first write down what the inside is. The inside is x plus f of x, and taking the derivative of the inside becomes 1 plus f prime of x. All right, and that's the end of that. All right, so then we have this. The next thing we need to that will establish we're trying to find out h prime of 1, and this will give us the information by that chart that we were looking at. So h prime of 1 equals to f prime of okay, so right now x is 1. All right, so let x be 1. So h prime of 1 equals f prime of 1 plus f of 1 times 1 plus f prime of 1. See, the fact that you have two f's here means nothing. You just keep working on it as usual. All right, so then what is all the stuff? Well, now you're going to have to look up from that chart of ours. Let's look at our chart. Where's the chart? Here it is. Okay, here's the chart, and in your book, and we have to follow the chart. So h prime of 1, which is what we're looking for, is f prime of f of 1 is 1, okay, according to the chart. I'm just reading off the chart now. F prime of 1, no, f of 1 is 1. Try not to read the chart wrong. If you read the chart wrong, then your answer is messed up. And then, but sometimes it's pretty easy to read the wrong column or something. And then 1 plus f prime of 1 is negative 2. All right. And then that equals to, what is f prime of 1 plus 1? That's f prime of 2. And you have to figure out what is f prime of 2. Look at the chart again. F prime of 2 is 4. Okay. I got this from the chart, in case you're wondering. F prime of 2 is 4. And then times 1 plus times minus 1, that equal to minus 4. And that is the right answer, because I checked. So that's number 249. You notice you have to look at the chart, but the problem is slightly interesting. Next, the last problem I want to cover is 257. Yeah, I don't think I have enough space. Let me wipe the board. Now, the last problem I want to do is number 257, where we measured some snowball. Okay, a snowball is melting, and we're going to figure out something about it. I'm somewhat interested in how a snowball might melt. So to do that, first we're given the formula of the volume of a sphere. The volume of a sphere is given as 4/3 pi r to the power 3. That is, I guess you don't have to memorize that formula, but it might be good if you did. It's just a matter of principle, that you should know the formula of a sphere like you would know the formula of area of a triangle or something like that. So, especially because the formula is pretty straightforward. However, we will cover the formula of the sphere later in calculus. So either way, it'll be good to know. Now, the radius is in terms of t, is given by this formula. Or maybe I shouldn't write it so close. All right. Now the radius of the sphere is given in relationship to time, is given by this formula. This is a formula where the radius is decreasing because the snowball is melting, and we're trying to figure out something about how fast it's melting. Okay? Now, part A. Use the chain rule to find the rate at which the snowball is melting. All right. In other words, we are trying to figure out what ds by dt is, and using the Leibniz rule, then it is equal to ds by dr times dr by dt. That is, we are replacing the u in the formula with r. Well, u, r, same thing. We don't care. All right, so first we'll do that, and then we'll do part B. Now, what is ds by dr? ds by dr, you go by this formula, okay? That is what you're taking derivative of, and you're taking the derivative with respect to r. So applying the power rule again, so we have 4. The 3 comes down and cancels, 4 pi r squared. And that's all. A quick and simple solution. And then the next one is slightly more complicated. Okay, what is dr by dt? Well, now you have a fraction to think of, but it's not that complicated of a fraction. So dr by dt equals to minus 2, using the power rule where the power is negative. Okay, that's the same as a negative 2 power, and minus 2 to this power t plus 1 to the power minus 3. okay? Or if it sits in the denominator, it's the same as a power -3. And then times the derivative of t, which is just 1. Because, yeah, there's nothing there, just t. And that is dr by dt. All right. Next, we have to calculate what is ds by dt. So here is that is so when we multiply this formula with this formula, we get the answer to part A, which is asking you what is ds by dt. However, what we want is then proceed to part B, where we figure out what is ds by dt at time equals to 1. So ds by dt, the rate that the snowball is melting at the time when t equals to 1 minute. So by definition, we need to take that and multiply by that. Okay, so that equal to 4 pi r squared. What's r? R is this thing. So we need to write that out. R squared. I'll write it out in a second. 4 pi r squared times dr by dt, which is that thing right here, which is -2 times, over t plus 1 to the power 3. That's ds by dr times dr by dt. And that would be given, that according to this formula gives us ds by dt. Now we will fill out what's in here. What is in here? What's in here is r, right? And r is this thing. So we need to write down that whole thing. 1 over t plus 1 squared minus 12. Okay, and right now we'll substitute. This notation just means t, we're evaluating t at 1. All right, maybe I'll stand over here. Now t equals to 1, so we have 4 pi. T is 1, that's 2, and then it's 4. 1 over 4 minus 1 over 12 is 3 over 12 minus 1 over 12 is 2 over 12, which is 1 over 6, and then squared is 1 over 36. And next, that is t is 1. 1 plus 1 to the power 3, that's 8, divided by 2 is 4. All right, that is minus 4. And then the 4 cancels out, right? So then we come down to pi over 36. And that's the answer. Now in physics, they want you to figure out what the unit is. Now from the beginning, it says something about feet. Okay, so the feet, and then per minute. However, being that it's the volume is feet multiplied by itself 3 times. That's how, cubic feet, so to speak. So strictly speaking, the unit is feet to the power 3 over minute. And that's what we've been doing. All right, so that's the end of the chain rule.